Hi guys, in today's video we have an integration. So we want to integrate this function with respect to x. So as you can see in this fraction, the degree of the numerator is greater than the degree of the denominator, and that would complicate a little bit our integration. So we want to write this down in such a way where the degree of the numerator is less than the degree of the denominator. So to do that, we're gonna perform a division of polynomial, right? So if we divide this x to the fourth plus 0x cubed plus 0x squared plus 0x plus 1, which is basically this numerator, right? And then we divide by this denominator, right? So this is gonna be x cubed plus 0x squared plus 2x plus 0. So we have x to the fourth divided by x cubed, so this is gonna be equal to x, and then we multiply x by this, right? So we have x times 0, which is 0, so we write it down here. Then we have x times 2x, which is 2x squared, so we have 2x squared, right? And then we have x times 0, which is 0, and then x times x cubed, which is x to the fourth, right? Now if we subtract, here we have 1 minus 0, which is 1, so we can write plus 1. Then here we have 0. Then we have 0 minus 2x squared, so which is minus 2x squared. Here we have 0, and here as well. So this is basically equal to this quotient, then plus this remainder divided by this, right? So this whole thing can be written as x plus the remainder, so minus 2x squared plus 1 divided by x cubed plus 2x, right? So our integral is going to be the integral of this with respect to x, right? Now this is equal to the integral of x with respect to x plus the integral of minus 2x squared plus 1 over x cubed plus 2x with respect to x, right? And this is equal to the integration of x is gonna be x squared over 2, and then we have plus this integral, so we can factorize this denominator. So on the numerator we're gonna have the same, right? And on the denominator, if we take x out, we have x squared plus 2, and then with respect to x. Now for this integration here, I'm gonna use integration by partial fraction. So this is gonna be equal to the integral of some a over x plus some bx plus c over x squared plus 2, right, with respect to x. Now we need to find a, b, and c, right? So if we copy this, so we're gonna put this whole thing in a single fraction. So we have x times x squared plus 2, and then on the numerator we have a times x squared plus 2, then we have plus x times bx plus c, right? Now this numerator here must be equal to this one, so we can write an equation where the left hand side is going to be this one, and the right hand side is going to be this one here, right? Now if we let x equal to 0, on the left hand side this whole thing is going to disappear, and x as well. So we have on the left hand side 2a, and on the right hand side this is gonna disappear, and we have on the right hand side 1, right? So if x is equal to 0, then we have 2a is equal to 1, which implies that a is equal to 1/2, right? So here we know that a is going to be equal to 1/2, right? Now we need to find b and c, right? Now let's expand this left hand side. Now if we expand this left hand side of the equation, we're gonna have ax squared plus 2a plus bx squared plus cx, right? And then we can factorize because we have x squared here, so this is gonna be equal to x squared times a plus b, and then we have plus cx plus 2a, right? Now this whole thing must be equal to the right hand side, right? So the coefficient of this x squared must be equal to -2, right? And there is no x in this expression, so our c must be equal to 0, right? So we already know our c is going to be 0, and then we said that a plus b, which is the coefficient of x squared, must be equal to -2, right? So a plus b must be equal to -2, but we did know the value of a. We said that a is equal to 1/2, so this implies that 1/2 plus b is equal to -2, which means that b is equal to -2 plus 1/2, which means that b is equal to -5/2, right? So we have a, b, and c. Now we can substitute them in our integration, right? By the way, there is x squared over 2 here, so now we can substitute them in our integration. So this whole thing now we can substitute a. We said that it's 1/2, b is -5/2, and our c is 0, right? So this is equal to x squared over 2 plus 1/2, and we have the integration of 1 over x with respect to x, and then we have -5/2 integration of x over x squared plus 2 with respect to x. Now integration of 1 over x, we know that it's the natural log of absolute value of x, so this is equal to x squared over 2 plus 1/2 times natural log of absolute value of x, and then we have -5/2 integral of x over x squared plus 2 with respect to x. Now for this integral, we're going to use integration by substitution. So if we let u is equal to x squared plus 2, this implies that du dx is equal to 2x. This implies that if we cross multiply, du is equal to 2x dx, and if we divide both sides by 2x, this implies that dx is equal to du over 2x. Now we can write this integral. So let's copy this integration. So this is gonna be equal to integration of x over, we said that x squared plus 2 is u, and then dx is du over 2x, right? So du over 2x. Now as you can see, x and x are gonna cancel out, so we have integration of 1 over 2u du, right? Now this is equal to 1/2 integration of 1 over u du, and this is equal to 1/2 ln of u, right? And we said that u was equal to x squared plus 2, so this is equal to 1/2 natural log of x squared plus 2. We didn't put the absolute value because we know that x squared plus 2 is always going to be positive, right? So we were here, so this whole integration is going to be equal to x squared over 2 plus 1/2 natural log of absolute value of x minus 5 over 2 times this integration, right? So we can copy it here, so times this one, right? And then plus a constant c. Now this is equal to x squared over 2 plus 1/2 natural log of absolute value of x, and then minus 5 over 4 ln of x squared plus 2, and then plus a constant c. So this is our integration.